unsteady flow description. 1, 2 and 3 dimensional flow we all know, like okay, this is x, this is y and this is z. So if we are just considering the flow in the x direction, just x direction, for example, if the velocity and this is a pipe, okay, now we know that okay, this is and we are considering this pipe like two dimensional, right? We are not considering the third circular dimension, we are not considering, just two dimensional pipe we are considering. So the flow, if we are just considering a flow like this one, that flow is starting from this point and reaches this way, so then that is one dimensional flow. But since now we can see that okay, this particle, or okay, the particle over here, this is moving in this direction, but it is also tend to go, means this due to this particle can go anywhere other than this streamline. So if it is moving in those directions, then that is termed as two dimensional flow. And if we also consider the circular effect, then that fluid particle can rotate, or means this particle can go anywhere, right? So in that case, this is termed as 3D flow. Now we consider a cube case example. So this is a cube. Now okay, this is a room. Now let's say that just if this is a fluid particle, if we are considering the flow just moving in this x direction, then this is called one dimensional flow. If we also consider that okay, this fluid velocity in the top side, then it means in the y side, means okay, this first velocity we are just considering x velocity. Now if we also consider vx and vy, then this is two dimensional flow. And if we are considering within the depth of the room, means if the flow not only in the height, but also in the width, across the width of the room, then we are considering all the three velocities vy, vz, then this is called three dimensional flow. Okay, so this is the detail of one dimensional, two dimensional and three dimensional. Now we will come to the last topic, which is of this chapter, which is system and control volume. So system is basically the amount of matter in space which is chosen for examination. मतलब कोई भी ऐसी चीज़ जो स्पेस में मैटर है जिसको आप स्टडी करना चाह रहे हैं, मतलब उससे आप देखना चाह रहे हैं उधर से वेलोसिटीज का फ्लो और ये वो, तो दैट इज कॉल्ड एक्चुअली सिस्टम. And anything around that system is called surroundings. और जो बाउंड्री, जो सरफेस सराउंडिंग्स को और सिस्टम्स को अलग करती है, दैट इज टर्म्ड एज बाउंड्री, राइट, एज कैन बी सीन इन दिस डायग्राम. So this is about the system, surroundings and boundary. Now we have the fixed and movable boundaries, as we can see in this piston case. Now this is situation A, at which the gas is present in this 2 kg of gas and the volume is 1 meter cube, and you are heating it. Now you know that due to heating, the temperature inside this increases, and that will result in increase in volume, as can be seen in this diagram. So volume is increased to 1.5 meter cube now. So but this is scenario B. So basically in scenario A and scenario B, the boundary is moving, so this is called movable boundary system. And if it is not like movable boundary system, like it's a closed system, then that is termed as fixed boundary system. Now there are two types of systems. One is closed system and the other one is the open system. Closed system is like when you are studying when there is no mass flow out of the system. There is no mass flow out of the system. We are just studying the mass within this system. So we are not discussing the mass going out of that system. That is termed as closed system. Remember that heat may be gone out of the system or work done, but we are talking about the mass, right? And the other system, which is open system, we just take the example of this nozzle, that the mass is coming in and the mass is going out. So we are studying this system with these are the boundaries. So that actually termed as the open system. This open system is also called control volume. So this is basically control volume or open system is a selected region in space, जिसमें आप मतलब इसकी एग्जांपल है जिस तरह आप स्पेस के अंदर आप नोजल को कंसिडर कर रहे हैं कि उसमें से मैस फ्लो हो रहा है, ठीक है जी। तो ये बेसिकली इसकी ये कंट्रोल वॉल्यूम होता है। एंड देयर आर मेनी एप्लीकेशंस जिसमें आपको कंट्रोल वॉल्यूम को मॉडल करके आपने एनालिसिस करना होता है। नाउ दिस केस, इफ यू सी द एग्जांपल ऑफ दिस केस, दिस पिस्टन, in this case there are moving boundaries, flow is coming in, and there are also fixed boundaries. So this is the case of open system and with the moving and fixed boundaries. So this is the example of the control volume. Okay ji. Now this is our last topic of this chapter. So now we will take the overview of this chapter. First of all, we study about the fluids, and we know that we explain that what are fluids and what are their basic properties like viscosity and other things. Then we study about the no slip condition. That is actually we studied because we want to know the interaction of solids with the fluid when the fluid is moving within the solids or over the solids. Then we see the classification of fluid flows, in which we study many types like natural and forced flow, laminar and turbulent flow, and compressible and incompressible, viscid and inviscid flow, and many other examples too. Then in between them we also see the different applications of fluid, and we see that the range of fluid is everywhere, like from real world problems to the minor problems also. And at the end we study about the control volume and the systems. So this will summarize the total chapter. I recommend you to go through the chapter 1 of Sengel book, because that will give you the brief of all the topics we studied here. Thank you very much, and good luck for your future. Thank you.